How many of you have used GraphQL before? Awesome, there's a couple of you. So I absolutely love GraphQL. I won't have too much time to explain it, but I want to talk about what I've been doing with GraphQL over the past couple days, and hopefully some of you find it a little bit interesting. So first off, who am I? I'm a software engineer at tinfoil Security. I basically write dynamic analysis tools. What that means is I'm doing runtime analysis of web applications to look for security vulnerabilities. Primarily, up till now, that's been in REST APIs and in more standard single-page apps. But I'm hoping to start doing this for GraphQL APIs in the near future. And we've been doing this with Elixir for about 4 years now. So first off, what is dynamic analysis? It's looking at an application's runtime to look for errors, whether that's bugs, vulnerabilities, denials, service vectors, that sort of thing. It's black box. We don't have access to source code, so it's just based on what behavior we can observe. For web applications, this is pretty straightforward. You start by crawling the app. You find all the input vectors. That's things like forms, links, local storage, cookies, just any way that a user can feed input into the app. And then you basically trace those inputs to see where they flow. Those are called the data sinks. And then what our goals are is to basically fuzz all of those user input sources to look for ways that we can exploit behavior in the application. So that could manifest itself as SQL injection or cross-site scripting or things like that. Basically, you're looking for ways where untrusted user input doesn't properly get sanitized or go through input validation and so on, and eventually ends up somewhere dangerous. So what does this mean for APIs? First off, APIs are traditionally fairly difficult to perform dynamic analysis on because they are not very discoverable. If you're dealing with a REST API, for example, you can't just open it in your browser and crawl it. So traditional techniques don't really work. GraphQL is really cool, though, because it lets you introspect the schema. Basically, you can send a query to the API, and it'll return all the types, all the unions, interfaces, the edges between them, the types of all the fields, that sort of thing. And so I'm able to use that to build a schema just from the URL of an endpoint. And then from there, my next goal is to basically get a set of representative queries that will try to cover all of the API's functionality. And then if I just pass those to my fuzzing engine, I can basically start looking for vulnerabilities in the GraphQL API for free. So what do I mean by representative queries? Basically, first off, there are going to be a set of queries that cover all the functionality in the API. So we visit every field, and we hit every argument that the API can accept. You notice we're visiting every field, not every type. The reason for this is that in GraphQL, resolvers run on fields themselves. So there may be more than one way to reach a given type that may have different authorization logic and so on it. So we care about the fields, not the types. And our goal is to minimize the number of queries we make. We don't want to just spam an API by sending 1 million requests at it when we can make do with 10,000. And we want the queries to be as simple as possible. We really want to be focusing on one slice of the API with every audit that we're performing. And that also means that we obviously want to avoid cycles because they're not telling us anything new about the API. So for examples of what I mean, on the right there, I just have a really basic graph of an example schema. Maybe it's for a forum. There's threads, users, and posts. You can get from the root to threads or users. And then from there, you can either get to posts or back to users and threads. A bad query would be the one on the side there where we go threads, posts, users, threads, posts, users, ad infinitum. That would not tell us anything new about the API, so we want to filter things like that out. Another example would be like that top query we have there. That's actually equivalent to just going to users directly and then to threads from there. So we want to filter things like this out and try to find the simplest queries that cover the entire API's functionality. So in this case, the representative set would be those two queries there. We want to go from threads to users, posts, users, and from users to threads, posts, threads. I'm going through this really quickly, sorry. But basically, given those two queries, we're hitting all of the query logic on the API. and from there we're good. So I have a mostly untested algorithm that I've implemented for doing this, and basically I first do the introspection query, get the schema, then I compute the line graph of that graph, which, if you're not sure what that means, basically I turn all the vertices into edges and all the edges into vertices. That basically lets me operate on the fields rather than the objects, because I care about traversing, or I care about visiting all the edges more so than I care about visiting all the nodes. Then I give each edge a weight equal to the distance from the root, and then the minimum spanning tree will basically just give me all the queries that I care about. So let's see a demo of this. Hopefully this works. I just built this in like the past 2 days. So I have a GraphQL API I found online. It just serves up all the Pokemon. Oh no. I can grab that. I can dump the schema. I can look at an abstract query I generated from that schema. I can convert that to GQL. And then, oh no. I'm so bad at using trackpad, sorry. Yeah. So if I just paste this into a graphical workspace, you notice it's parameterized with all the arguments that those queries take. Just pass in an argument. Oops. And bam, we just queried a whole bunch of Pokemon from an API that we knew nothing about except the URL for. And if I just pass this stuff to my fuzzing engine, now we can find vulnerabilities. Cool. That's all I had to talk about. We're hiring. Hit me up if any of this sounds interesting to you.